Hello, this is Mr. Inkling. In this video we're going to be looking at 2.3 notes, function notation. So function notation when we use f of x instead of y. So function notation when f of x, that's how we read that, f of x is used instead of y. Okay? So we have the example here, f of x equals 2x plus 5 is the same equation as y equals 2x plus 5. So the y value is just getting replaced with this f parentheses x. And the way we say that is, again, f of x, or the function of f in relation to x, or f is a function of x. Okay? Now, what is very important is we need to know that the letter f is the name of the function, not a variable. Okay? It is not a variable, it is a name. So it is not f times x, it is f of x. It is the name. Now, we can use a lot of other letters, as we see in this quick example here. We can have g, we can have h. Again, these are just the names of the function. This, again, becomes very, very useful when we graph, use like decimals or something to graph our functions, and we actually name multiple different functions that we're working with, and we're able to name them. That's what allows us, that's what makes the function notation very useful. And then we're able to recall that function later on. But our first skill right here, we just need to make sure that we understand how to rewrite using function notation. And so, very simple again, like we set up there, we're taking the y and just replacing it with our function notation. So our first one, y equals 3x plus 1, would become f of x equals 3x plus 1. The next one, y equals negative 4x. Again, replace it. And let's use a different name for the function. We used f over there, so let's say this one's g. Function g of x equals negative 4x. All right, example 3, we have y equals negative 2x squared. Well, let's name this one h. Function h of x equals negative 2x plus, or negative 2x squared. And then we have our last one there, y equals 3 to the power of x plus 4, a nice exponential function. And let's say this one's b, function b of x is equal to 3 to the power of x, and then plus 4. So again, we can use any letter. Really don't want to use x of x, that doesn't really make much sense. And y, we use x and y, those are variables that we use for graphing. So pretty much any other variable, though, could work pretty well. We have t of x, s of x, anything like that. All right. And just again, just to make sure that we are clear on how this is said, if you see f of x equals 2x plus 1, that is how you say it. F of x equals 2x plus 1. It is f of x. We want to make sure that we are saying this clearly, f of x, or g of x, or h of x, whatever our function is, that is what our name would be, and it is that name of x. Okay? All right, so let's go ahead and look at our next skill. So this one, we want to go ahead, and I'll just zoom it in on example 1 here. We want to evaluate a function for a given domain. So remember, our domain are the x values. So we have f of x. They want us to calculate or find what f of 3 is, given that f of x is 3x plus 5. Okay, so what does this mean, finding f of 3? So let's write that underneath, f of 3. Now let's think about what we are given. We're given f of x equals 3x plus 5. Well, what changed in my f of 3? The x did. Instead of x, I'm replacing it with 3. So then we would do the same thing in our function. So that would be 3 times, and instead of x, I'm now replacing it with 3 plus 5. 3 times 3 is 9, plus 5 equals 14. So f of 3 equals 14. So all this means is that we are plugging in 3 for x. And that's all f of 3 means. F of 3 just means I'm taking the 3 and I'm plugging it in for x. So let's go ahead and see another one. So f of 4, what does f of 4 mean? Well, this is our, again, that is our x value that we are plugging into our function. We want to get an output, a y value. Okay, remember these are all functions, so we're relating inputs and outputs. So our input is 4, our output, well, we got to see what that is. So that means we are going to plug in 4, so f of 4. So instead of x, I'm replacing that with 4, so that's going to be 4 squared minus 3. So let's see what our output is. So that would be 4 squared is 16. 16 minus 3 is, well, 13. So f of 4 equals 13. Now, one thing I didn't do on the last one, but I can actually now write that as a point. So knowing that information, I know now for that function that my point would be 4, 13. And let's actually just go ahead and do that on the last problem as well. So this would then tell me that we have a point 3, 14. Okay? All right, let's go ahead and do one more. We have a new function, naming it g, and we want to evaluate it at g of 4 and g of 3. So let's go ahead and do that. So first off, we want to find g of 4. Remember, that just means I'm plugging in the value 4 into my function, which is 3 to the power of x. So that's going to be 3 to the 4th. Well, what is 3 to the 4th? Well, that's just simply 3 times 3 times 3 times 3, which is 81. So again, let's write that as a point. So that tells me I have the point 4, 81. Input of 4, output of 81. All right, g of 3 then, g of 3. Same function, it's function g. I want to go ahead and plug that in, so 3 into my function, so that'll be 3 to the power of 3, which again just means now I'm doing 3 times, which would be 27, which means I can write, I now have the point 3, 27. And so that is how we evaluate functions at a given, or given values. So if I want to find f of a number, well, that just means I take that number and I plug it into the function. All right, so we have some practice down there. I'm going to go ahead and leave that for you to do. I'm going to go ahead and go on to our next example. So skill number 3, we're going to be evaluating functions using a graph. So we have the graph of f of x here. So this graph is representing f of x. And I want to find these different values. Now notice, I'm not told what the actual function is. I don't know what f of x is equal to, okay? But we have a graph, and so we'll be able to still find it. Even though I don't have the function, I can still find what f of negative 2 is. Now remember what we said. That means that 2 is going to be my x value. That is what I'm replacing for x, and that is the x value I'm looking at. So if I want to find f of negative 2, all I need to do is look at the graph, go to negative 2 on my graph, so that is over 1, 2. Here is negative 2 on my x-axis. Remember, this is an x value, so it's inside the parentheses. And now I just determine what my output is. So my input is 2, and so I go down to my graph. Here's my point, and now I go over. What is my output? My output is negative 5. And that's it. Let's go ahead and do another one. So next one, my input is 1. So remember, that is our input, or x. So I go to positive 1. Here's positive 1. My point is already on there. So what is the y value, or the output? Well, I'm already here, so I just go over, and my output is 0. So 0 is my output at x equals 1. All right, let's do next one. We have an input of 4. So what is my output? So let's just go over to positive 4. It's 1, 2, 3, positive 4. And let's find my output. So I go up to my point on the graph. There it is. Now let's go over to the y-axis. And there is my output, positive 5. So f of negative 2 just means I'm looking at what is my output when my input is negative 2. What is my y value when x equals negative 2? Well, I just use the graph to determine that. All right, D, E, and F take the same idea but go backwards. This time it says find the value of x when f of x equals negative 1. Now remember, f of x, we learned right at the beginning, means y. F of x is always replacing with y. So this means, what is the value of x when y equals negative 1? Well, we just go to negative 1. Here is negative 1 on my y-axis. Let me use a different color. Here's my y value of negative 1. Let's go ahead and find an x value. So what is the value of x? X equals what? All right. Well, here's a nice point over here. What is my x value? Oh, my x value is positive 2. However, is that the only x value that we have? It is not. I also can come over here. This point is not marked, but it is still a point on my graph. So I have positive 2, but I also have, and this one we're going to have to estimate, but we also have about, let's say, negative 1.3. So when you do this one, you have to find all the x values that go with that y value. Okay? All right, so E. Let's go ahead and look at E. Let's do this one. All right, so what is the x value when my y value equals 0, or f of x equals 0? All right, well, here is 0. Nice 0 there. What are all the x values? And there again is more than 1. What are all the x values when y is equal to 0? Well, I come over, and here's an x value when y is equal to 1 at negative 1. So x equals negative 1. I come over, I find another one at x equals 1. And that one we had kind of already determined up here. Y equaled 0 when x equals 1. Perfect. So positive 1, but I have one more. I keep on going. I see another place where y is equal to 0, and that is at positive 3. So we actually have 3 x values for when f of x is equal to 0. All right, let's go ahead and do the last one, and then that last problem will be for you to practice. So this one, what is the value of x when f of x equal to positive 1? Positive 1. So let's go ahead and go up to positive 1. Here's positive 1 on my y-axis. So we already have a nice point there. And so I can go ahead and say, well, at positive 1, we definitely have an x value of 0. So x value of 0, but we have more than that because I can come over and have another point at positive 1. And that one, again, we're going to have to estimate, but I'm going to say that's about 3.3, positive 3.3. Now, it's really hard to see, but there is technically one other point, because this graph, let me zoom in and see if we can see this a little bit better. This graph does go above that positive 1 y value a little bit, so we do technically also have a point right here. And so I would need to, let's say that's about 0.4, negative 0.4. So we also have that one. All right, so that is how we take a graph, and we're able to evaluate different values on a graph using this function notation. Just remembering what is my x values, determining the inputs, finding the outputs, or if I'm given an output, finding what the inputs would have been. All right. Awesome. So that concludes this lesson. If you have any questions, please let me know.